Hi, welcome to the inaugural LiSA Information Systems Conference, which took place on Wednesday the 4th of September 2019. So I'm recording this video the day after the conference because when we checked the video feed and the live stream, it turned out that there was 10 or 15 minutes at the very start which got corrupted. So when you're watching the video which is about to come up, it starts about 5 minutes into the first keynote speaker, and it also misses the initial introduction, which I'm just going to repeat here now. So the conference, LiSA stands for the LSE Information Systems Alumni, and the purpose of the conference was to bring together LSEIS alumni and students so that we could share ideas and strengthen our alumni group. And the conference was structured so that it could be used as a future template for the same purpose, to strengthen the alumni network. So we live streamed and recorded the conference, and one of our speakers joined us remotely from Norway. So we did this on purpose. We wanted to live stream out outside of London, and we wanted at least one speaker to stream in and give their speech remotely. This is so that we could include people in the future that are outside of London, because of course most of our alumni are not based in London. So yeah, I'm just going to give the introduction again because we missed it on the video, and then the video will just jump a few minutes into the first keynote speaker. So our speakers were, first of all, Professor Leslie Willcocks. Well, Professor Leslie Willcocks, he's the editor-in-chief of he's based here in the LSE, of course, and he's the editor-in-chief of the Journal of Information Technology, and has co-authored 57 books and published 230 papers. So Professor Willcocks' research interests include service automation, robotic process automation, cognitive automation of knowledge work, artificial intelligence, digital transformation and emerging technologies. And Leslie's keynote talk on AI and business ethics set the tone for the rest of the mini conference. Our second speaker was Sally from IBM. So Sally works within the IBM Watson team in the data science and AI group here in London. Sally works as a cognitive computing specialist, and she helps businesses create a competitive advantage through the use of cognitive technologies that can understand, reason, learn, and interact. So Sally discussed how IBM handled bias in their AI systems. Our third speaker, as I mentioned, was Christian, and he Skyped in from Norway. Now, Christian is a recent MISD graduate, graduated this year, and during his studies he focused quite intensively on artificial intelligence and did his thesis on that. So he worked as a summer intern as a data scientist for US-Norwegian AI startup CRISP, and is currently working for Bearing Point in Norway as a technology analyst for the data and analytics team. And then our final speaker was Rosa Z. Khan of evolution.ai, and she spoke again in a much more detailed way on bias within their AI systems. So Rose is a machine learning expert and has worked with Dun & Bradstreet, Money Supermarket, RBS and Oracle. And as mentioned, she continued the discussion on bias, and her talk ended with quite a lively audience discussion as well on various issues around business ethics and AI. So then we just thanked some of the people that were involved in organising the conference. So on the committee we had Maria, Sophia, Mamaya and Alex. And now Mamaya and Alex were actually alumni, they weren't students, but the four together organised the speakers. So Alba and Cha worked on marketing. So Alba did the artwork for Eventbrite and the artwork that you may have seen on Facebook. And Cha reached out to our Chinese MISD students from the 1819 class and from the incoming 1920 class. Vanessa worked on networking and on the catering for the event. Then Henning, Christian, who spoke, myself, Cathal, Manuela, Vivian, Ian and Liz were also on the committee. So on the academic staff then, we'd just like to thank Professor Avdru for helping us organise it, and she kind of spearheaded it or started it back in October of last year. And thanks to Professor Leslie Willcocks, who, as I mentioned, was our keynote speaker. And on the professional services side, we had Hamida and Caries, who helped with marketing to the alumni network and other things. Kevin Brett gave us some tips on software use. Rob and Chloe did a lot of work. Rob throughout the whole year, and Chloe in the past month, and especially in the day or two before the event. And then the AV department, who on Monday and Tuesday before the event and on the day of the event checked in and made sure that we had everything that we needed. So with those introductions done, we will just jump now into our keynote speaker, Leslie Willcocks, and it's about 5 minutes into his speech. Thanks.
All these things are true. They don't have mindfulness. So, and they really don't get context. You never can give them enough context. And that is a real problem with all these designs. It's hackable. We've seen too many examples of that. We've just, this week, I think, had the iPhone story. I hope you have not been reading that, because one more horror to face in the daily round of horrors. But evidently it's been hacked for a very long time, so the iPhones. So what do we do about that? How can we stop people from hacking? Build more secure bunkers, I guess, to stop it. It's amoral. There is no moral compass except the one that we program into these machines. And our moral compasses are not perfect, and they can't second guess every situation. So we have a real problem there. It's biased, inherently biased, because all the data that goes into these machines is biased, because it's from an actual living, breathing origin. It's not come out of a vacuum that says, I am unbiased. It's highly invasive. We know that privacy can be greatly compromised here. And it's very blurring, it's very fakeable. You can create a fake picture of someone, or make them look from 75 years old like me to 33 quite quickly. You can do all sorts of things now with these technologies. So you've got poor old Boggs Habib, who's got a heavy wagon of moral compromises here that you have to deal with, and real challenges that we're going to have to face up to when we start looking at this seriously. Next slide then also talks about the driverless vehicle is an interesting one. I just don't believe it's going to happen to any great degree. I think there's a gradation of a level of automation of driverless vehicles from 0 to 5. And I think most people think we're going to get to 2, and then there's going to be a number of problems trying to get to 5 along the way. But it immediately throws up some very interesting moral dilemmas. Just to give you some feel for this, this is what is known as the trolley problem, a very old problem, but I just developed this for the executive program that we've developed for the LSE. It's running quite soon. Quick advert for that 6-week online program on cognitive automation and artificial intelligence. But one part of that is the ethics of automating. So let's just look at this just to get you some sense of how complex this can be. So it's a very simple invention by me. You're in a driverless vehicle and you're going down a 3-lane motorway. The lorry in front suddenly drops its load right in front of you. What do you do? As a human being, what do you do? Well, you save yourself, don't you, naturally? So you do whatever it is to save you and the driver. But if you program a algorithm, what do you do? If you swerve to the right and hit a motorcyclist who's not wearing a helmet, is that a good option? Or is the preferred one swerve to the left and hit a motorcyclist who is wearing a helmet? Then that way you cause harm to the person who is being good, but nevertheless you probably hurt them less. Or do you drive straight into the load, risk harm to you, your car and your passengers, and possibly the lorry driver? Anyone got an answer to that one? Remembering that programmers aren't necessarily the most morally sensitive of people, will they even think about these options? Can they second guess the other infinite number of options that you might have? So scenario 2, perhaps you could swerve to the right and hit a car with a responsible driver, swerve to the left and hit a car with a person driving at the speed limit, and is driving without his seatbelt, or drive straight into the load and risk harm to you, your car and your passengers, and possibly the lorry driver. Now, when they ask people, what is your moral preference out of these scenarios, they said, well, we prefer that it's programmed to protect the innocent. On the other hand, I won't be driving a driverless vehicle if you program it like that. I'll only be driving a driverless vehicle if it's programmed to save me. So we've got an interesting ethical dilemma there at the point of decision as to who we're going to put at risk and who we're not going to put at risk. So you get these massive challenges. So if we move on to the next, how much time have I got?
Okay, another 8 minutes.
All right, well, I can probably do 5.
But won't the lorry itself be programmed somehow to do something, so there'll be some compatibility between whoever's on the road and the lorry? So maybe that mismatch that creates this dilemma doesn't even exist to start with.
How do you program the law to do that?
I don't know. Just, we're all making assumptions. I don't know. Maybe there could be a way where the lorry would be also programmed somehow. To do something so that two cars.
Yeah, well, the best law would be we don't have driverless vehicles, therefore we don't inherit the moral dilemma. Or we have automation to the point where it's controlled by a human being who understands the ethical dilemmas that they are facing. Because the program couldn't possibly exhaust the possibilities, in my view. I just can't see how they can. Another area that people jump up and down about in the press and media, certainly, is what about all these job losses that's going to result from automation? Surely there's an ethical dilemma there. Well, it's a misunderstood area would be my response to that. If we go to the next slide, people talk about job loss as if, you know, everyone in this room, 47% of you are not going to have a job within the next 10 years. That's the way it's positioned. But that's an anchor figure from a study done in 2014 about the US, which basically didn't say that 47 people will lose their jobs in the USA. What it said was that these jobs are potentially highly automatable, or at the risk of being automated. That's not the same thing at all. But that's an anchor metric that everyone then believes. We've backed off from that, including I never really believed that anyway, wrote a book in 2016 that said that was pretty nonsensical, really, the 47% figure. But when you look at the most recent studies of this, it turns out, you know, relatively big hitting serious studies, Asia Development Bank, McKinsey Global Institute, drawing upon quite big evidence bases, PricewaterhouseCoopers, World Economic Forum, and our own, I've got a pending paper coming out on this. When you look at all that, the potential job loss that they are talking about, net job loss in the next 12 years is 1% globally. Net job loss of 1%, not 47%, 1%. Are you still worried? Well, the real issue, of course, is not that it's a net job loss of 1%. The real issue, and I'm going to skip the next slide because I don't want to, it's my paper in one slide, but let's move on. Okay. I think I've made the point. The real issue is skill shift. But the whole issue of job killer is deflecting from the fact that the real issue is skill shift. The real moral ethical dilemmas is, are we going to educate people for the new world that we are creating when we digitize and automate? And by the way, it's not automation that's the real issue, it's digitization, which involves a range of technologies, of which automation and knowledge work is only one out of about 10. And it's the integrated nature of the digitized technologies that is the real issue. And when you look at that, what that's doing, and I've managed to synthesize out the whole area, is moving jobs from the left-hand side, jobs that are repetitive, physical, non-technical, non-cognitive, involve basic human and low skills, to jobs that have a mix of the skills on the right-hand side. And it's not that the jobs will disappear that are based on the left-hand side. say that there are 44% of jobs at the moment are on the left-hand side in the global workforce. That will reduce in 12 years to about 32%. So it's not a complete wipeout by any means, but what we should be doing is focusing on the dilemma of how we increasingly educate people onto the right-hand side, and that's not all technical STEM skills. Many of them are cognitive and distinctly human skills, like critical thinking, empathy, social intelligence, that are going to be more necessary in the future than they are at the moment, because machines can't do this kind of work. And there's a very interesting ethical dilemma there for governments, corporates and individuals about how far they should be investing in that future. So if we move on to the last slide, I hope I've raised a number of issues for you in my 20 minutes. If you want to get really interested in this in terms of automation, we've done 3 books and we've got another one coming out in October. There's a pamphlet here that discusses all that and gives you the website details where we have conversations about ethics. And I've got a limited number of an article I wrote for Forbes about 2 weeks ago called "Are We Facing AI Armageddon? What's Wrong with the Automation and Future of Work Debate?" You can download it from Forbes for free anyway. So for the moment, I'll stop there and we'll throw it open for questions, and any of the other speakers can help me if the question's more down your line than mine. Okay.
First off, thank you. I found that really interesting. I had a question, just trying to get an understanding of the cognitive automation bit.
Yeah.
One of the wrenches, the data wrench, I saw labels that said difficult data
Yes.
and dark data.
Yes.
Could you possibly tell me what that is?
Yeah, sure. I'm going to be consistent with what I've told people before here, so I'm just looking it up. But dark data is, by definition, by the use of the word dark, something you can't really see. So what have I got it down as? Untagged data, so you just can't see it. Hidden in the bowels of data storage data. Not easily available data.
So you're talking about data that could be useful to train a neural network, but it's not in the data set that it's training?
Yeah, untapped, unstructured, untagged would be my definition there. Difficult data is things like fuzzy images. So I was at the University of Sydney recently, and they developed, a bit naughtily, one of the problems they have, we don't have it here at the LSE, but sometimes students sit exams for other people. So they developed this face recognition software, it's at pilot stage, whereby a person entering the exam hall there would be a face recognition software. And you couldn't always get a good picture of that particular person, so it would say, no, we haven't got a good enough picture, take another angle, and then it would confirm that against a database of faces. So, if you only had the first iteration and the person was hiding behind a pillar and was deliberately obscuring their face, then it would render the data unusable. So that would be sort of what I would call difficult data. Dirty data is missing data, duplicate data, inconsistent data. So we did a study of a bank recently, and we found that when you looked at all their data coming in or stored, only about 15% was actually usable for cognitive automation.
From a background where it's like data is data, like if it's unusable data, it's still usable in some way, but that's fine.
Well, not by the cognitive technology.
Right.
Yeah, because by definition, if it goes in, you get crap coming out the other end. That's the problem. You can't get around that problem. One of the myths of big data is that you just shove it all in the garbage can and miracles happen and a shiny new car comes out the other end, sort of thing.
Yeah.
it doesn't happen. It doesn't work like that. And all data going into these stuff is dirty, more or less, because it's socially constructed, more or less.
Because I've heard the term data lakes becoming data swamps, because there's no understanding of what the data is, where it's come from, who actually uses the data, and then it's just there. We need to collect all our data, put it in one place that's accessible, but nobody actually knows what the use of it is. So there you've got a real data that's just wasted.
I've just had a thought, which is that the other interesting thing about that is the data is limited. Even if it's clean data, it only takes you so far. So, for example, there was a study done of how many people died on the Titanic. And what was interesting when they ran the correlations, you know, they got all these data sets and ran it through a cognitive technology algorithm, and they found that the majority of survivors were women. I think it was something like 77% of the women survived and about 33% of the men. So what's the explanation for that? Well, again, you know, it didn't come up with an explanation, it just had a correlation. So they worked it out that actually it was because women and children were placed in the lifeboats first. Okay? So that was interesting. But then they discovered that your chances depended upon which lifeboat you got into. And that wasn't anything that the correlations threw up, because you didn't ask that question at the start. But when you read the stories, the rich stories that humans would read, you discover that the captain said, put the women and children in the boats and then leave. And the guy on the starboard bow, the first officer interpreted that mean put all the women and children in first, then fill up the spaces with men, then let it go. The guy on the port side interpreted that mean put the women and children in, then go. Both sides had empty seats, by the way. But you were more likely to die if you were a man on one side than the other. But the machine would never pick this sort of stuff up because it wouldn't understand the context or the rich data. So this is sort of interesting imperfections in terms of the data that you feed in, the correlations you get out at the other end.
I have a question regarding the cost on intelligence that artificial intelligence creates. So this is an experience I'm having nowadays. So I watch a lot of YouTube, and say I...
You do?
Yes. So say today I watch your lecture, which is an hour and a half, but I probably would watch maybe 10 or 15 other videos who are 1 minute and less meaningful and about something silly. I would prefer to have YouTube give me feedback and recommendation about lecture like yours rather than the other videos. But the way the system works, apparently, it gives you more of the, because you know, it gives a number, right? So 15 videos of something, it gives you more of that. So I'm becoming more stupid because of Facebook. And also the same thing is happening to me with Facebook.
Can I quote you on that? Can I quote you on that?
Yeah.
He is more stupid as a result of Facebook.
Yeah.
Right, thank you.
YouTube, right? So I'm thinking over time, there will be less choices of meaningful content for me and more crap.
Yeah, it peaked around about 2006 in my experience. You got very good guidance about then, and then the way that things were ranked changed, and you know, and popularity was more important than good or meaningful.
Exactly. So
to that particular
it's
audience.
a risk, I think, to human intelligence in the long term, because you know you will be prompted with less meaningful content, something that will advance your career or your meaning of life, to something, you know, some guy jumping on the roof because he has 1 million views and you don't.
Yeah,
You don't
but remember, humans program that to happen that way. You know, they programmed the ranking system. It wasn't. I mean, the machine just does what it's told in that sense. Yeah.
So just the last question.
One more question.
Yeah.
Yeah.
What's your definition on AI? Because like in the
AI?
Yeah.
Using computers to replicate what minds can do.
Okay. And which of these technologies you classify as AI? Because many of us would just argue that things like machine learning and deep learning would be statistics more than actual learning, right?
Yeah, they call it learning, but it's not. It's an improvement on the previous performance according to a certain metric. Is machine learning, but essentially it's highly dependent on very traditional statistical techniques that depend on correlations and probabilities. That's all it is. It's jumped up. It's statistics on steroids. That's what we've got. That's what we're calling AI, statistics on steroids. In that particular example, I'm not denying that AI exists. What I'm saying is I can't find it in general corporate purpose use anywhere. I've looked for 4 months and I can't find them. It depends how you define AI. I would respond to IBM Watson.
I was going to go do that.
But you're next.
Very good. Thanks, Leslie. Thanks very much. It was a great talk. Okay.
Oh, sorry about that. You just plug it in.
So actually, you can bring that with you if you want.
Okay.
Just click on that and then tell me if you want to go back. Yeah.
Okay, well, I need to go
By
back.
the way, we have done studies of IBM Watson in corporate
Good.
setting.
Good. Hi everyone. So my name is Sally. I'm from IBM, mainly focusing on the data science and AI section of our IBM. I currently look after industrial sector, but I've looked after retail, financial services, pretty much every industry. I've touched upon it at some point. So for me, half the things we're going to talk about, Leslie's touched on already, but I'm going to look at it in terms of what businesses are doing and what we see ourselves doing in the market as well. So Leslie was correct. AI is very much a term that's been branded around. It covers analytics, it covers data science, it covers a whole stream of things. For us, we classify it as augmented intelligence. We're helping our clients, whoever they may be, wherever they may sit, to improve the processes that they have currently. So it may be in customer service, it may be internal capabilities that they've got going on. How can we help you be better at what you currently do? How can we make sure that your employees are getting the most out of the job that they're doing as well? So that's one thing I'm going to go through. So within our platform, we have a whole stream of different things. But before we got here, as Leslie showed up, in 2011, we took part of Jeopardy. That was our big kind of showcase of what our capabilities were. We won that. We beat the person who'd answered the most correct answers, as well as the person who'd won the most amount of money in Jeopardy history. So for that, it was a big achievement for us, because we were showing the world, look at us, this is what we're doing now. Since then, we've broken up those capabilities that were initially used in Jeopardy to make up these new capabilities. So we've got Watson Assistant, which is our chatbot capability, so conversational tooling. So in some websites, instead of you talking to a human to answer your basic FAQ questions, there's a chatbot answering it. So it understands natural language and is able to discern exactly what you're asking for and provide an answer. It could be in text format, links, videos, or just a simple, you may need to speak to somebody else, I'll pass you over to a human handler, because there's certain things that a bot can't handle. There's certain things AI is not ready to handle, but it's understanding that and being able to process it and train your AI in the right way. So when we talk about AI, we don't think humans are going to be out of the training process. I always say, if I'm going to meet a client, do you have a team ready to help you build this? Because we can build it for you, but it's your internal teams that will know your business best and how to drive this to be a solution that will be impactful for your business. So whenever we're deploying a chatbot, there's always a team from IBM and a team from the client working together. We know the technology, they know the business, and we work in partnership to help train it to make it useful. There's speech to text, everyone has an Amazon Alexa or Google Home, all of those types of things. Those are the main capabilities that are within those toolings. It's just being able to give a command and the command being actioned in some type of way. So it could be fill out my Excel spreadsheet for me with these features. I've spent this amount today, and that's an RPA thing, because it's you having to do a manual feature, but you can plug it and do really cool stuff with it. natural language classifier and translator, basic things that we all need to have. We compete with other people, so we have to be viable within those terms. Discovery, which is one of my favorite services, because that's allowing you to look at documents and being able to query it in natural language. So that's saying, I've got this lecture paper, I don't want to read it all, I'm going to ask a question and it'll take me directly to that section because it's read the whole paper, understands where the different sections are, and it'll take me to where it is. So we've used it in different industries, which I'm going to touch on soon. And then the Watson machine learning, Watson studio and catalog. These are the data science plays that we have as well. So instead of just looking at what businesses are doing, because all of our capabilities are designed for the business user, this is more, I know Python, I know R, I want to get hands-on, I want to create my own algorithms, and how can I do that myself? So that is some of our capabilities. Tone and personality insight, they're quite cool. They're not 100%, but it gives you an insight to the person. So if I know I'm going to meet somebody for the first time, I may just put their Twitter into personality insight to just see some things about them. So are they authoritarian? Are they quite relaxed? Or what kind of things do they like as well? So I can see those type of features from some of our capabilities that we have. Didn't go. There we go. As Leslie mentioned, we are really at the start of our AI data journey. A lot of people have reams of data that could be spanning over 100 years if you are a company like IBM who's been going for so long. But then they don't know exactly where that data is or what type of data they even have. So majority of people, they say they want to be a data-driven company, but they're at the start of their journey. Only 15% of CIOs, CTOs actually know what data they have and how to use it properly. We're trying to get to 100% of people being data-driven, but that comes with the understanding of, firstly, I need to understand what data I have, what do I want to use it for, and what is the most viable thing that I can put in place to help me there, and then the internal politics, because with change comes restrictions from senior management, from even just the developers, as well as the people who are using it as well. And that's something that you have to take into account when you are talking about data, AI, or anything, the people aspect of it as well. It's not just, oh, you're going to put me out of a job. It's also about how is it going to affect my job currently, and how is it going to affect the future of what I'm doing. Humans versus machine. It's always one of those things where it's kind of like, if I implement this tooling, that's it, I'm out the door. But we see it as humans and machines working together, because you can't train a bot with your previous chat logs, because that will be faulty, because the chat logs are filled with people giving their response of what they think is right, rather than what should have been said, which is representative of the company's values and tone of language as well. So you have to think about, how do I want to train this? What do I want the outcome to be? So it's all about humans and machine working together. And one of the quotes that I've come across, which I really like, is data fuels digital transformation. AI unlocks the value of data. So you have to understand where your data is coming from, who's going to be training it, and what type of toolings you need to make sure that it's effective and driving your business in the right way. So the industries, as I said, I have worked or touched base with different types of industries. So I'm going to start with insurance, because everyone's coming into contact with insurance at some point. So insurance companies right now are looking at, how can we make our processes more streamlined and more quick? Because if you have a car crash, it may take a month for it to actually be processed. How can we use AI to speed up that process, but to make it also accurate? So it's looking at, I've had a car crash, I can take a picture of the crash, I can get a valuation of how much it's going to cost me if I go through insurance, or if I want to go through a localized mechanic who's around the corner. And it's just understanding of what data is driving that. Is it historical data that, oh, my insurance premium is a lot higher than my mum's because of her age? I may have passed my driving test 5 years ago, and she's only passed hers last year, but because of her age, she's deemed as a safer driver. So all of these algorithms are already in place in our historical data, and that's what's being used to train our possible insurance claims that are coming out as well. So if I have a crash today, but because my mom is older and she has a crash tomorrow, my tariff may go up, but hers may stay the same because it's an accident. It happens to the best of us. But I was probably deemed as speeding or something like that. So it's understanding that these different industries are using data that may be 10, 15, 20 years old, but it has to look at exactly who was training that data at that point, looking at what changes have happened in different areas as well. So if you said Brixton a few years ago, people say that's a no-go zone, don't touch that. But Brixton has got gentrified. Some parts of it are amazing. So your tariff may have been a lot higher 10 years ago. It may drop now, but because AI has been trained 5 years ago, or they're using data from 5 years ago that's old and out of date, they may still have that mindset of it's an unsafe area, your car's likely to be broken into, your house is likely to be broken into. So we have to put a higher tariff on that to make sure that we can cover it when something happens. But it's not keeping current with, oh, we may need to look at what has happened recently in the last 6 months to make sure that we are keeping up to date with exactly what is happening right now. When we look at healthcare, so Memorial Sloan Kettering Hospital, so yes, they for people who don't know about Memorial Sloan Kettering Hospital and IBM, in 2016, after the whole Jeopardy and us coming out with capabilities, we looked at healthcare because healthcare is a big thing. Everyone touches it. And for doctors to keep up to date with all of the research that is coming out, they'll need to read for at least 46 hours per day. That's not possible at all. So it's about how can we make the information from research around the world accessible to the doctors while they are on the hospital wards rather than sitting in their offices reading and then seeing a patient. So we're taking out that time that they could be with patients, giving diagnostics or just explaining what the terms are. So with this, we trained a tooling and that was focused around doctors being able to see the patient records in a simple page on an iPad. They can scroll through, they can update wherever they've seen more up-to-date results, but also it gives recommendation about best possible treatment, which is available in the country and within that hospital as well. So in the US, all hospitals are very much siloed. They run as their own individual businesses. So this was very unique to that because you can change it and adapt it to be like, well, it's got basic training from Memorial Sloan Kettering Hospital, which is one of the best research hospitals for cancer in the world. But also, I've got information from thousands of other doctors and researchers around the world about certain drugs that I have access to and what could be the possible outcomes as well. So that is the work we did with them. Yes, they stopped working with us, but that tooling is still being sold around the world and is in use as well. And it's saving lives because you're giving the doctors the power to make decisions. So the final decision always comes back to the doctor and what they know as well. But we're able to put a lot more information in their hands to make that final decision. It's not saying, Watson said, yes, this treatment's the best, so we have to go with that. It's about saying, I know this research has been done in Thailand and this is the outcomes that it's had. Also, we can try it here and see what we get here. But also looking at the individual patient and making the treatment more customized to that person as well. But also, when it comes to healthcare, we're looking at how can we make sure that the right people are getting the right organs. It's not based on you live in Oxford, you're going to get better care than if I lived in Milton Keynes. Milton Keynes has a lesser, the hospital rate is, lost my train of thought. The hospital rating is less than Oxford. So if I need a kidney transplant, somebody in Oxford is probably going to be ranked higher than I am. We're taking away all of those types of unconscious bias that we may have as humans to think that if that person's here, they're going to receive a greater treatment than if they were somewhere else. But looking at the individual patient and seeing their outcomes and seeing what probability of life that they have based on them rather than what we think about the areas and all of those types of things. As humans, we have we're susceptible to over 150 types of biases. And when we put that into AI, when we put that into our training sets, it means that we are just repeating our own mistakes. And until something happens, we won't notice it. Police. So in the US, they started trialing a visual recognition tooling to be able to identify offenders. That right there is a huge problem because data sets in visual recognition, you need 100 different types of data sets to make to train just a simple model. So it could be identifying a person, different types of food, or all of those types of things. You need 100 pictures of the same thing in different lighting, in different environments to make it more accurate. So your example about them using it in exam halls, that is going to be very skewed because different lighting, somebody may be wearing a different shirt, they may be wearing a hat, glasses, all of those types of things will skew it. You're comparing it to one picture you took of me in year 1 of me starting uni. In year 3, I've changed my hairstyle, I've got glasses on, I'm wearing a hoodie. You can't tell me apart from me here and now to when I first started uni. So all of those types of things will affect the quality of the outcome and also the training sets that you have as well. Let's be real, the majority of people in IT labs are majority white males. So when there was a study done, and when they looked at the comparisons of the different genders and the different ethnicities, when looking at white males, it was 99% accurate to say you're a white male, you're this age, and so forth. White females is about 60, that's not bad. Black males drops down to about 40. Black females of dark complexion, it drops to 35%. That's scary that I may be arrested for something that somebody else has done, but because I'm a black female and I've got a certain hairstyle and the AI tooling thinks that I match that person, I could get arrested for that. And who am I to argue with that? Because the AI tooling has said, that's you, and you committed this crime. And it's something that we do have to understand as well. Customer service. Everyone wants to give the best customer service. Us as consumers, we are very driven to get the best. If I can call you, I want to call you. Ideally, I don't want to because there'll be a long waiting line on the phone. If I can reach you online, I want to send an email. That may mean that you take a week to reply to me. Oh, you've got live chat. Great. Oh, there's a 10-minute wait. I'm that person. I will not wait 10 minutes to speak to somebody. If you're not accessible right then and there, I'll be off to the next person. So customer service bots are becoming a huge thing across different industries. Healthcare, financial services, insurance, even industrial sector as well. So when you're speaking to suppliers. But the thing is, who is training it? How are we training it? What data is going into that? Is it records that we've had from 10 years ago where we used to have certain products but we don't have anymore? Is it people who saw at a customer because they got really mouthy to them? All of those types of things we need to take into account. And when you come to training your AI capabilities, understanding exactly where do you want to be seen in the industry and as a company as well. What tone do you want to portray? What kind of personality? Do you want to be fun and bubbly? So one of my first ever projects I did within IBM was a first-time buyer mortgage bot. The bank were like, we want it to be fun and interactive, so we want you guys to use emojis, we want to use GIFs, so when you first say hi, it's a waving whale or a dog smiling at you, all of those little things that they think first-time buyers want to see. No, if I'm going to be spending my money and signing up to something that is going to be 35 years of my life, I want it to be very serious and go straight to the point. But they thought that as millennials, we like all of those types of things and we want it to be funky. No, just get straight to the point. So it's having an understanding of your end user as well. It's not just about the business needs or the developers' needs. It's about the end user. What did they want to see when they open a page? What did they want to see when they start talking to a bot and so forth? Ooh, let me see if there's anything I missed. Data. Data. As we were talking about earlier, there's good data, there's bad data, there's dark data, and it all comes in different forms. So when you're looking at it in terms of visual recognition, is it fuzzy? Has it got the correct lighting? Has it got a certain background? What kind of things are we trying to use it for as well? Because I know one of the projects we did, the person wanted to see if there was greenery on their platforms. Okay, but the pictures you've given us have 10 of platforms, but majority of them are of bricks falling out of the wall. So do you want us to look at the spalling rather than the greenery? Yes, actually, yeah, let's do that. Because people come into AI thinking, I'm going to switch a button and it's all going to work for me. There's a lot of training and there's a lot of data that goes into it to make it work. And you have to think about, where is my missing data? Where have I standardized it? And where actually is it? Because a lot of people, they may have databases from 10 years ago of information that they think is irrelevant or they've forgotten about, but they need it right now to make them a data-driven company. So it's having that understanding to push them forward and having an understanding of what needs to be done to help them on that journey as well. So it's always, as much as you want to start an AI journey, you have to think about, where is my data, who owns my data, and what can I do with it? But then also, do I have the skills I need within my company, or do I need to hire somebody? So do I have a data scientist who qualified 10 years ago that I can give them a revamp and give them and upskill them to make sure that they can do this job? Do I have a customer service agent who is the best customer service agent in my company that I can help train on an AI tooling that they can train it to be the best bot in the whole industry? Do I just generally have the right people and the backing from senior management to say, yes, we believe in this, to fund a project as well? Because AI is not £10 and here you go, you've got a bot that's running on your website. It's a funded activity internally and externally. So do I want people to come in to help me build something, or do I want to do it all internally? But also the software and the maintenance of the software, do I want it a managed service, or do I want my internal team to manage it for me? So it's having that understanding and it being a business-driven activity rather than just I think it's a great idea, let's start something as well. Diversity in teams as well. So when you're talking about, I'm building a visual recognition bot and it needs to do X, Y, and Z, who is helping to train it? Do I have a diverse data set to make sure that it will actually do what I'm trying to ask it to do? But also, have I created a culture where people feel confident enough to speak up when they see errors happening, where they see biases being portrayed in certain data and just certain actions, and before it gets built into something that can last for 20 years, making repeated mistakes as well. One thing we are doing within IBM is creating new capabilities that will be able to spot where bias is being portrayed as well. It's called IBM OpenScale, and that's being able to say, well, you've just gone through the insurance calculator and this is the outcome. But me as an insurance worker, I can see exactly what different criteria was touched upon before that outcome was made. So if I see that, because you're under 25, that's why they've said your tariff needs to be higher. Why? How long ago did you pass your test? Have you ever had a car crash? Have you ever... All those different criteria need to be taken into account, but sometimes it is overlooked. It's just focused... It gives more leverage on one thing rather than looking at it all as a balance as well. Here, I'll just, thank you and questions. No questions? Great, thank you. Sorry.
Thank you for that. That was really interesting, Sally. One of the areas that we're seeing a lot of bias is in recruitment. AI is alleged to be kind of removing biases in recruitment, that people are submitting things and AI is reviewing things like video interviews. But obviously if you're applying to a company and the company's not very diverse to begin with, what kind of reassurances are places like IBM kind of offering people that if you're, say you're a financial organisation and your staff is predominantly white male of a certain age, how do you ensure that the AI isn't picking up similar people? How do you ensure that those biases aren't passed on to AI?
No, definitely. Great question. So one of the things we do work on is looking at the skill set rather than the name or where you went to school and all of those types of things. So schooling may play a factor, but it may be that you went to a decent university, but you've worked your way up into a company, you've got the certain skills needed for a certain role. So that would be the main focus rather than just your name is Sally Nunekpeku, you're of African descent, I don't think you'll be a great fit here. But it's more, let's get you through the door, let's meet you face to face, let's have the conversation and see exactly where you are and what kind of skill sets you can bring to the table rather than looking at just the core value of, oh, your name is this, that's what we're going to focus on. Does that make sense?
And things like video interviews that rely on AI, presumably they've interviewed people in their company. How do you ensure that the AI isn't just penetrating more biases, it's just interviewing people and perpetuating biases because it's interviewed people with a bias?
Yeah. So the thing is, with those video interviews, you can use a speech-to-text language, so you're taking away the actual visual aspects of them, and you're looking at what they're saying. So picking out the key aspects of what they're saying and matching them to what your job spec is, rather than saying, well, you looked like you were sitting in a £5,000 apartment, so I think you could fit in here, you wear a Rolex or whatever, those types of things. Because those are certain cues that people as humans will pick up to be like, you sound like me, you seem like me, so I think we will get along, so you should be here, rather than you actually meet the criteria that needs to be in the office with us. Sorry.
I'm just curious to know, you can answer this either as yourself or as your company.
Okay.
Don't worry. Just because we're talking about ethics.
Yeah.
So just curious your thoughts on ethics and boundaries, given that many of us may have watched the Netflix documentary about a certain company.
Yep.
Just your thoughts around AI in politics or defence. Just want to get a feel for whether you feel there are any boundaries within AI.
So I'm going to go as myself because I definitely don't want to speak for IBM. So I think we are in a changing world, and what we expose of ourselves to others online and so forth is it's scary. One of my interns found my mum's home address online because of a mistake she did. So she listed a company, didn't know the whole process, so she put our home address, and I was shocked because I didn't know it was out there, but he found it in less than 20 minutes. And I was like, that is really scary. But the thing is, we have to get to the point where we have an understanding of where the legislation is going to come from. And as Leslie said, we are 7 years behind, plus even. So it's not just about automated cars. It's looking at what information we do have out there and us being able to read the terms and conditions, because it's always hidden in there, and being able to decide, this is how much I want to limit of myself to social media, to employers, and so forth. So it's very difficult to say. It's a developing field, and it's just having an understanding of what do I put out there and how could this affect me as well. So I think it's one of the things that education is a major key for that. So one of my things I speak to my little brother about, he's 14, so he's growing up with social media. He's got a phone, he's got Instagram, he's got Twitter, all of it. I'm just like, think of yourself in 10 years down the line and see what could come and bite you in the ass. Because that's the only way you'll actually be conscious of what you're putting out there as well.
He's still 14, he won't know.
Huh?
He's still 14, he won't know.
But then there's stories, so...
about kids and their parents putting them online as well. You know.
That's the thing as well. I wouldn't know... I don't have any kids, but I know there's only a select group of people that I would want to see my child. So I would put it on WhatsApp groups because I know exactly who's there. Facebook, I would definitely shrink down my... the reach of that, because I can protect that. I can make things private. But it's also...
Smart, you know this stuff. Most people don't.
But that comes to my point of education as well. So it's starting young as well. So I always tell my little brother, look at Kevin Hart. He was going to host the Oscars, but a tweet he wrote 5 years ago came back to bite him. So that is a limited opportunity for him. Do you want to be that? Because you may be taking the right steps in your adult life, but then when you go for a job interview, oh, we've seen that you posted this tweet when you were 16 about X, Y, and Z. How do you feel about that now? You can't backtrack because that was your mindset then as well. So it's very difficult, and I think education does play a lot into it.
Just to add to that, because I think this is the most juiciest part of the debate. Just even with respects to, I think that maybe we need to revisit human rights as well, because if we think about people in developing countries, they may not have a choice as to whether they're part of a certain data collection system.
Yeah.
And effectively being, well, I'm trying to find a polite word, but being exploited from a data perspective as well.
Yeah.
But if that's their only platform for accessing the outside world, what can they do? So maybe we need to think about how we adapt or think about human rights, because not everyone will have the opportunity to be educated on their rights, so maybe human rights needs to change as individuals.
100%. I agree with that. Sorry, one last question.
Just last question, yeah.
Yep.
Thank you for your talk, Sally. So naturally, I recognise that your main stakeholders at the senior level are going to be CTOs and CIOs at the respective companies within the respective fields that you pitch to basis. But do you find that you have to engage people like CFOs who are equally focused on using artificial intelligence to boost operating profitability, for example? And what kind of things do IBM use to engage individuals who don't speak that language per se, the language of tech, and then do you have individuals that can speak that language?
Yeah, so great question. So when you are talking to the CFO who's kind of saying, I want to cut 200k of my expenditure, how can we make this happen? You have to look at the effects of that on the company as a whole and the individuals. And because then you've all seen the stories of, oh, IBM came in and took my job kind of thing. And it's not about that. It's looking at how can I make your job better and more easy and easier. So we don't always look at the financial benefits when we are talking to clients. So maybe how can I help you improve your NPS? How can I help you improve your standing within the industry? How can I cut down your hours spent on replying to emails? All of those types of things. So it will translate to money in the later stages, because if I'm cutting down the hours you spend replying to emails, it means that your employees can be spent doing something else. They can be trained up to be advisors rather than just email monkeys and so forth. So it's all of those types of things we need to look at. In terms of connecting to people who don't speak tech, I'm kind of that person. So I've got technical sales, but I'm more the account management person. That will be, what are you trying to do? What are your business goals in the next 5 to 10 years? How can we help you on that journey? Even it could be as short term as, what are your goals for this quarter? Oh, you've got a budget of IT that you want to spend. What is the main problems that you have within the company right now, and how can we use AI or data to solve that as well? Because my remit is not just AI, it's also looking at data science as well and analytics. So what kind of issues do you have in terms of planning, in terms of optimization, decisions about what pallet to offload from your trailer rather than X, Y, and Z? So it's all of those types of things as well. So there is a different way of doing things.
Oh, great, thanks. Thanks, Ellie. So we're going to have an online talk now with Christian, who's coming in from Norway.
Switch. No questions, yeah? Oh, right in the front, great.
Hi, Christian.
Hello.
How you
Can
doing,
everyone
Christian?
hear me all right?
Great. Can you hear us?
Yeah, I can. Yeah, absolutely.
Okay. So Christian is Skyping in from Norway, and as I said, it was important for us that we do at least one remote speaker, just so that we can kind of establish a template for future conferences and for this conference. And Christian, as out of the MISD group from last year, Christian is probably one of the most people who concentrate on AI and deep learning. And Christian, you can take it away and explain your experiences in building your first models.
Thank you so much. Thank you so much, Cal, and the team for having me. And I'm looking forward to speak to you all. So I'm. Oh, there you go. A little bit of a delay. Yeah. So I'm part of the current MISD, the cohort, and I've been focusing my degree on data science, working as a data science intern this summer, and now employed as a technology analyst in the data analytics department of the consultancy firm Bearing Point back in Norway. And what I'm going to take you through today is a specific challenge that you face in building models, and specifically, without getting a little bit technical, but not too technical, how to ensure that these models are actually things that create a positive impact for you and your business. So let's see. I'm going to show you some stuff here. Sure. So this should come through now.
Yeah, we just can't
Cal,
see.
can you just confirm that? Yeah, we got it. Brilliant.
On the right side there,
Yeah. So my talk's called The Business Impacts of Artificial Intelligence Predictions, Designing a Forecast Evaluation Model for the Food Supply Chain. And this is essentially a quick run through of what I did for my thesis this year. So first question to you all, how do you know if your AI model makes you any money? Now, we hear a lot of talk about AI, and we hear a lot about talk about how it can be used in organizations, but it's sometimes hard to figure out how do you know if this actually has a positive business impact. And through this talk, I'm going to take you through a very specific challenge that we encountered to this and how we solved it. Now, as you've heard, the current practice is to use performance measures. Leslie touched on this. Performance measures in model selection. So you measure how good the model is doing, usually using some kind of statistics. As essentially a lot of AI and machine learning is statistics on steroids, as it was put earlier. However, as you can see here, we make an AI model on the left-hand side, which has a technical performance, and then this has some kind of business impact. But it's sometimes hard to link this to what actually happens in your application domain in terms of your business performance. And there's a lack of measuring the business impact of this performance, at least in current data science practice, where mostly statistical measures are used, not necessarily linked to business value. So what we tried to do this summer was to create the link. The artificial intelligence model will make some kind of prediction, and then you can measure the prediction error impact in the application domain. You measure the cost of each error, which means that you can actually train a model to specifically optimize the performance based on business value. And this sounds pretty straightforward. It gets a little bit more in depth, but it is you can do three things. You identify what are the types of losses that are caused by different types of errors. Now, as I'm get into, in our case, we were doing forecasting. So you can either predict too much or too little. And depending on your context, that has widely different implications. Now, we were in the food supply chain industry, so we were dealing with things like expiry dates and those kind of things, operational challenges. You can also see, as been touched upon in terms of crime classification and image classification, how different types of errors can lead to different types of losses. In a business context, what happens if you misclassify something for example, an insurance, and you grant someone insurance that should not have been granted, or you set a wrong premium, or you set also taking those things into account. You want to quantify these impacts and losses, and then to figure out how hypothetical models will perform or different models will perform, you want to create some kind of simulation so that you don't put something out into the real world that has negative impacts on your business. So, and how was this done? Essentially, it was done in the context of the food supply chain. And as everyone knows, I'm sure there's a lot of food waste. Approximately 1/3 of all food production is wasted or lost every single year. And the startup I was working for this summer is looking at specifically the US market, where 161 billion US dollars is lost annually just to food waste, which is about 2.5% of the US energy consumption. So these here, okay, let's see if we can get some technology to help make this situation better. The company is using data essentially on currently focusing on demand data for the food supply chain to drive more precise forecasts. So we're very much in the field here, specific application domain of supply chain forecasting, which is already building on a lot of statistics. However, some of the things that we touch upon are also applicable to other domains, as the way we went through to identify these errors and measure the costs are things that can be generalized into kind of consulting type frameworks. So what's our problem? Well, we had two models. We had the yellow and the blue that were our models, and then we had the green that was the actual demand. And as you can see, it's not quite clear here which model is better. So in data science, you need to make a decision. Which model should I use? Or should I use this setting or this setting? And there's many, many technical decisions you have to make throughout the whole data science cycle. And here we are looking at two different artificial intelligence models, where we have Amazon's DeepAR Plus and Facebook's Prophet, which are both time series forecasting models. And regular practice is to use in data science a percentage. So it turns out DeepAR Orange was 0.0173% better. Okay, so what? I'm a business manager, I'm the client. Why should I care about this? Well, what's the impact on my business? And specifically, if I am ordering chicken that goes out of date tomorrow, I don't really care what the average is, because if I don't sell my chicken today, then it's out of date. Okay, so we need to create something that is slightly more sophisticated. And this is essentially down to the general problem in data science and AI, the need for an objective measure of goodness, of model goodness that reflects actual business impacts. So not necessarily the average over a certain time frame, but something that is adjusted to how this will actually run within the business. It is done to some extent already. Depending on, for example, you would prefer to be referred in medical predictions, you would prefer to see a doctor one time too many than too few. So those things are done already. But in terms of making a precise impact analysis, that is what we were trying to do here. We use design science research, as those familiar with information systems research might know. The essence is fairly straightforward, not going to spend too much time on it. Essentially, you find a context and a problem, then you figure out what tools you can use to design that and address that problem, and then you work on iterative problem, and artifact design. And the important part here is to get customers into the fold and have an iterative dialogue about what is meaningful to them. So, what's the situation? We're talking here about augmented human intelligence, as touched upon by the other speakers. We can see on the left-hand side here, we have our little stick man called the order person, and this is the guy who he wants to order something for his production line. We can also see that there are time constraints, so something happens right now, time 0, but then you don't actually get the order until time 1, which is tomorrow. However, what you have is the forecast for this week, and you have the forecast for next week. You also have your production, inventory, and incoming. You have your production numbers and your inventory numbers that are set to this time frame, but incoming orders only come the next time step. So you need to make a decision this week about what's happening next week, essentially. So what we did was to make a set of hypotheses, which we iterated on with our clients. And essentially, we identified the losses. You can see here, we have broken down. So the forecast losses in over forecasting and under forecasting, and then down to storage, cost of capital. Here the next one's supposed to be expiry cost, and then opportunity cost and customer goodwill loss. These are very measurable things, with the exception of goodwill. How do you measure the goodwill of a customer? Now, what we found through industry engagement was that in the supply chain, especially food supply chain, it's very important to keep a certain service level. So this was also seen as an important measure. And that allowed us to essentially answer this question. Which of these two models should we use? Again, this is our forecast and demand comparison. Quite hard to interpret. However, based on the above, we get this. Profit on our simulation is 200,000 or more than 200,000 US dollars better in terms of savings. And that's really powerful in several ways. It obviously states the business performance of the model. So we're able to link the model to the actual business performance. And it also allows us to measure why should you use AI? Why should you use or machine learning, or why should you essentially go from using traditional statistical techniques or advanced statistical techniques that are called machine learning or AI, whether depending on your labeling. Um, because what we found is that a lot of the time these models perform a lot better, which means that even though it's not conscious and it definitely cannot think on its own yet, it allows us to predict things a lot better with very, very real business impact. So a little bit more detailed. Things often happen. Things get slightly more complicated because it turns out there are also other measures that are important to our clients. We can see here, first we see how the different losses compare over time. And here we can also see some more of the information we were able to give them. Was a hypothetical inventory modeling. So how much would you have in stock at a certain time? So, and this goes back to the point about augmented human intelligence, because this would be then someone at a warehouse or someone who is responsible for ordering who would know, okay, we have a certain capacity on our warehouse. We've modeled depending on this, but it's important for us to keep a certain level in our warehouse, or it's important to keep to a certain service level because, yeah, if you're supplying someone big, say, yeah, I can't say the actual names, but if you were supplying someone like Tesco, you're a small supplier into Tesco, drop beyond a certain level, obviously you're out of business. So that's more important than being a couple of quid, yeah, extra. So to answer our first question, how do you know if your AI model makes you money? Well, you just measure if it does. And that is essentially it.
Thanks very much, Christian. So, Christian, if you can just hold on there, if anyone has any questions for Christian. Okay. Yeah, just because it's online, you can just speak into this, Alex. Okay.
Yeah.
Just keep it about 6 inches.
Christian, Alex here, mate.
Hey, brilliant. Hey, good to see you.
How are you?
I'm good.
Yeah, I have a question. So, obviously, with big firms like Bearing Point, IBM, and all your big tech giants, you have your architects and solution engineers who are really the guys who are writing the code to build platforms for their clients or for their internal business systems. So really, what they're doing is they're taking, like you said, a problem and designing the artifact to solve it or to mitigate it to some extent. So really, the control is in their hands, and often there is a bridge between engineers and business. So really, the ethical side of the debate sits in the hands of the solution engineers, because they're the guys with the hands on the artifact. I hope we can agree on that. So my question is, from your experience, is there enough being done to bridge that ethical gap between the business side of an organization and the guys who have their hands over building these systems and solutions for clients? Because really, you could get given a brief and go away and design something that hits your business objectives, but actually is socially unacceptable. So I wonder, from your perspective, do you think there's enough being done, or do you see things being done to bridge that gap between engineers and the ethical side and the brief from management? I hope that's clear.
Yeah. Thank you so much for the question. On this particular project, I was fortunate to work for a company who's trying to save the world, essentially, in terms of food waste. But I'm guessing it goes more in terms of the social impacts of data use. And to that extent, you can see that this really depends on the dialogue between engineers and business managers to see if you meet business goals, but also depends on internal ethical guidelines and things like this. In Europe, obviously, we have GDPR, which sets out a set of regulations. So companies and consultancies operating above board will be very, very mindful that GDPR is compliant with in terms of data management and those kind of things, which also starts the ethical discussion about what kind of data you can use for what kind of purposes. And then there's a lot of questions we also actually need to have as a broader, both as a business community and a society, about how do we what do we want our data to be used for, and the data we've given away freely, are we okay if that's being used to create a better offer for us? Say if your bank can offer you a better rate because they know that you're a safe person, do you want to do that? Or at what extent, or at what point does that go into the bias area, and also at what point does it go into it kind of neglects the point of insurance, which is to kind of save people against force majeure events where you're an unfortunate victim of an accident and you want to have some kind of common ground for that. So to answer distinctly, I find in my experience there is a dialogue around it, but I've also through following media and following documentaries and things like that, I do know that it varies, and it is easy from practice. I know it is easy as a data scientist to treat data as just data. And it's really important to keep linking this data and the impacts that you're having to the real world, because when you're working on a model, then what you're trying to do is to make a good model, and that looks very similar whether you are looking to sell someone something or produce more oil or whatever. I hope this answers the question.
Yeah, thank you.
Thanks very much, Christian. Thanks for connecting and giving an interesting talk, and just let's hear it again for Christian. Thanks.
Thank you so much. Take care, everyone.
So our final speaker is Rose, and we've kind of heard each of the speakers now has at least mentioned bias. All the three speakers now, and we're going to take a bit more of a deep dive into bias and other issues. And let's throw that on there. Is this? Yeah, you can just put that under the lapel there if you can. Okay. Yeah, so you can take it away, Rose. Oh, I'll load up your things here. So you can control over that if you want to.
Oh, okay, cool.
If you want to go back,
yes,
just let me know.
Okay, hi everyone. So quite a lot of people have left, but I assume. That's left. Okay. I assume you're all sticking around for the free drink, so you're probably not going to leave halfway through my talk, at least. And this can be more of a medium dive rather than a deep dive, because I think we've run over a little bit. Anyway, so the topic of my talk is bias in, bias out, and I'm going to be talking about bias in machine learning algorithms, which has already been touched upon by two of our previous speakers, I guess because it is a very contentious issue around AI applications today. So my name is Rose. I'm a software engineer at evolution.ai. So I'm just going to talk a tiny bit about our company. So we were formed in 2015, and we produce machine reading software. So our aim is to be the most accurate machine reading platform on the market. And most of the stuff we do involves extracting information from documents. So if you're a company, you have hundreds of thousands of documents, then you can upload them all to our platform. We will extract information instantly. And these are the kinds of tasks that one of the common tasks that AI is replacing, as Professor Willcocks touched on in his talk. Basically repetitive manual labor that can be done much quicker by a computer than by a human. So I'll just talk quickly about some of the things that we do. So as I said, a lot of our projects are based around extracting information from documents. So for RBS, we automate the extraction of information from invoices. Again, this is something that was previously done manually, and we now do it automatically for them with an accuracy of 98.6%. Another of our big projects with RBS is automating KYC. I'm not sure if people are familiar with KYC. So KYC stands for Know Your Customer, and it's something that banks do when they're onboarding a new customer to a bank. So we've automated much of this process for RBS and for a private bank as well. And this is the use case I'll be talking about most in this talk, and we'll see how this relates to ethics in AI. So this is just some background on KYC, or Know Your Customer. So the outcome of these checks determine whether a business can become a client of a bank, and ultimately whether they receive a loan, whether they receive financial backing for their business. So it's a pretty significant outcome for these businesses, and it has a significant impact on the business and on the people running the business. Similar checks are carried out for onboarding individual customers and for deciding whether individuals receive loans. So by replacing these checks with algorithms, we are doing something pretty significant, and we want to ensure that these algorithms are making the right decisions. We want to know that the outcome is fair and consistent and reasonable, the same way we would want to know this if it was a human performing these checks. However, it can be more difficult to figure out the reasoning behind an algorithm than it can be to figure out the reasoning behind a human decision. With a human, you can just say, hey, why did you make this decision? With an algorithm, it can be a bit more complicated. So I have a really short introduction to machine learning, as I wasn't sure whether people would be already familiar with machine learning. So I'll just go through this quickly. So this is the standard process of machine learning, is you have a bunch of data and you want to predict some outcome of the data. So for example, you might have a data set of house prices, and in this data set you'll have a lot of features of the house, number of bedrooms, maybe square meters, location, postcode, garden, etc. And you want to predict the price of a house for which you don't know what price it's been sold at. So you will build a machine learning model to predict this. And the model learns a mapping from the features to the house prices. So now you have your machine learning model, and you've just put in all the data, and it's come up with, it's learned a function, and as part of this function, some features of the house will end up being weighted more highly than others. So for example, the number of bedrooms will probably contribute more strongly to the price of the house than, say, the color of the front door. And you input the features of another house for which you don't know the price, and it predicts the price. And you look at it and you think, this seems pretty reasonable from what you know about house prices. And the main point to understand here is you haven't chosen which features contribute to the price. You've just put everything into the machine learning algorithm, and it has figured out which features contribute most to the price and has weighted those features accordingly. And this is kind of the promise of machine learning and AI, is you don't need to know that much about the data. You can just put all the data in, and it will just come up with predictions, and you think, great, like, let's put this in a business application. But often, this also means that you don't know the reasoning behind these prices and behind the predictions. So back to the main topic of my talk. The topic is bias in, bias out, and I'm going to talk about how bias arises in machine learning applications and how we can avoid it, crucially, and how we can tell whether an application is biased. And this links to what I mentioned previously with the Know Your Customer checks that we do at evolution.ai, is that when you're building an AI that makes decisions about people's lives, you have to know the reasoning behind these decisions, and you have to be able to tell whether it is biased or not. So the importance of unbiased data is, I think, as Professor Willcocks mentioned, data is not automatically neutral. It's generated in the real world by real humans, so it will contain biases. I don't know if you've heard the term garbage in, garbage out in relation to machine learning models, which basically says, if you have bad data, like, your model will be bad. Like, there's no way to build a good model from bad data, from dark data or difficult data. And the same goes for biased data. If your data is biased, then your model will also be biased. Ultimately, your model is only as good as the data that you have. And if you build a model using biased data, then you risk creating biased real-world applications. And when these are used to make decisions about people's lives, these decisions can then be biased and unfair. So we want to avoid that, ideally. So I've got some examples of biased AI. One example is voice recognition software that doesn't recognize certain accents or dialects. So, for example, Siri, I think, was recently pretty bad at recognizing Scottish accents. And facial recognition software that only recognizes faces of white people. And in both of these examples, the bias is likely due to the data that the model has been trained on. So the bias is essentially an underrepresentation of data for these minority demographics, for anyone with an accent other than Southern Standard British English or American English, and for anyone who is non-white, basically. I have a kind of anecdote about this. So I used to work for a speech recognition company, and we built a speech recognizer for UK Hansard, so to be used in UK Parliament. And we realized quite far down the line that it basically did better at recognizing men's voices, and this was just because we had more audio data for men in our data and less data for women. And so this is partly due to representation in government, but I think also in certain committees where the representation was maybe more or less equal, men still spoke more often than women. So we just ended up with a lot more male data, and that was a bit worrying. So in these cases, one thing you can do is to supplement the data that you have. So I think we tried to supplement our data by just getting audio data of women in general. So the way to get around this voice recognition software would be to build data sets or find data sets of people with different accents and use this. Another thing is that this kind of bias can maybe be more easily avoided if by having diverse people working in technology, because I feel like then the problem will be caught earlier. You can imagine maybe someone building a voice recognition software who has a Southern Standard British accent, and they say all kinds of weird things to it, and it recognizes everything that they say. And they're like, oh, great, 100% accuracy. But that's obviously not the case.
If you make the data more inclusive, will it make the model worse or different? Like maybe it gets mixed up, so it doesn't know exactly what to do.
I think it would make the model better, because it would be able to generalize more to, like, the more different kinds of data you have, the more different kinds of data you have in your training data, then the more it will generalize when it sees new data. So I don't think there's a case in which it would make it worse. So this is quite a controversial example that I wondered whether to include, but Compass is a tool used in the US to predict whether someone will go on to reoffend, and the prediction used of this tool is used by the judge to make their decision of whether to grant bail to someone. And it's been argued that this tool is biased because it basically predicts that it predicts more black people as high risk of offending, and it makes twice as many false predictions that black people will go on to reoffend as white people. And the problem with this is that if you've predicted that someone is high risk and this influences the judge's decision to grant bail, and they don't grant bail because of it, you don't even know what the real outcome would have been. You don't know whether they would have gone on to reoffend because you didn't grant bail in the first place. And another problem with this that's been argued by some people is that the US criminal justice system is already unfair, that black people are disproportionately likely to be denied bail, to be sent to prison, to receive longer sentences, to be sent to death row, and once on death row are more likely to be executed. So any algorithm trained on data generated by an already biased system will continue to perpetuate bias, which is inherent in the data. So this is a pretty serious example. I think there's some contention about this because I also read another paper which said that they basically, that this algorithm does predict reoffense to, like, quite accurately, but a bunch of random people from the internet predict reoffense just as accurately as this algorithm. So if you're using an algorithm that's no better than a bunch of random people that you find on the internet, how good is your algorithm, really? Or does it matter? So a final example would be a CV scoring algorithm, which predicts how good a candidate CV is for a job. So this is another anecdote from a previous place that I worked. We decided to build a CV scoring algorithm, and we basically ended up with a scoring algorithm that was biased towards people from Essex, because it just so happened that over half of our company was from Essex, and we just put the whole CV in, including the address, because most people put the address on their CVs. And so this is not something that we really wanted to base hiring decisions on. This algorithm was never used in the hiring process, but it just goes to show that you need to be really careful when you're deciding which data to put into your model, because especially when you don't know what the model is learning, it could be using any of these features to predict the outcome, and you just see the score, you think, okay, great, this person's a good fit for the job, without really knowing the reasoning behind this. So I think that's the main point in my talk. Yeah, so in general, in the world, everyone has huge amounts of data, customer data, web data, historical data, recruitment data, and also machine learning and AI are pretty accessible to anyone, which is a great thing because anyone can download TensorFlow and build a machine learning model very quickly and with quite limited knowledge. And also utilizing your data can be a huge benefit to your company. You can figure out what your customers want to buy, who will default on their loan, and in general, how people are going to behave. So everyone wants to use their data to their advantage. And any decision-making process, which is data-driven, can in theory be automated. And some of these decisions have serious implications on a personal level and on a general level. Some decisions might be who gets benefits or who gets access to healthcare or who gets a loan. And so you want to be sure that your algorithms are making the right decisions in these cases. Another point is that this is one of the main benefits of AI, is its potential to automate these decisions. You can scale massively where this wouldn't have been possible before when it's humans making these decisions, and this is a benefit. So for one of our clients, Dun & Bradstreet, they estimate that we save them about 10,000 hours of manual work per year through automatically extracting information from documents. So this is a good thing. However, it also means that if you're using an algorithm which is making biased decisions, this then has the potential to affect a huge number of people, perhaps more than would be affected by a biased human decision-making process even. And it might also be more difficult to pick up on the bias or to somehow compensate for it. Like, whose fault is it if an algorithm is biased? So I'm going to talk about Know Your Customer, which is something I mentioned briefly at the beginning. And I'm going to talk about the work that we've been doing on automating this. So as I mentioned before, these Know Your Customer checks determine whether a business can become a client of a bank, which in turn might determine whether they receive a loan or other financial services, which can have a significant impact on the success of their business. All of these checks were previously carried out manually by a human case handler, and we want to know that the decisions made are reasonable and fair and consistent. So these are some of the checks that we do as part of the KYC process. We identify inconsistencies in the forms filled out by businesses. We scrape the company website and we check that what they say on their website matches up with what they've put in the form. We detect any mention of sanctioned nations on their website and in their form. We spot financial misconduct and we check whether the assets and revenue that they've declared seem reasonable. And the way we do this last one is we have a data set of historical KYC data, which we've trained, and we then see whether the assets seem to fit in with similar businesses with similar revenues. And if any of these seem a bit dodgy, then we flag it and we send the form to a human case handler. So these are just some of the results of our automating this process. So the time taken to process a single case was reduced by 90%. We exceeded the 94% accuracy, and we exceeded the accuracy of human case handlers. So this is a pretty strong case for automation, a case where automation has definitely been a benefit to RBS and to the private bank who are our clients. This is an example of one of the checks that we do. So we check if their trading description matches the given SIC code, which is a standard industry code. So we predict the SIC code from their description of their trading on their website, and then we see whether it matches the one that they've put on the form. And if it doesn't, then we flag it. But crucially, we flag it with a reason. So we say, this is why we predicted this code. So when it goes to the human case handler, they immediately know what the potential issue might be, and they know why we think it might be a bit of a dubious application. So with Know Your Customer, we've tried to make the automated process as explainable as possible. This is not a black box process where you simply send an application and the system returns a yes or no answer with no explanation behind it. We identify the parts of the form which seem anomalous and with the specific reason, and we send it to the human case handler, who can then kind of do further investigation of the more complex aspects of the case. So this is a semi-automated solution with a human in the loop. Okay, so using AI to eliminate bias. So I've talked a bit about how AI can perpetuate bias, but it would be good if we could avoid this problem. So I think there are two main ways that we can try to avoid this problem. One is to understand your data. So as a machine learning engineer, before you build a model, you should really understand the data. You should probably do some statistical analysis of the data and figure out which features you want to include in your model. Think about what you're trying to predict and whether you would expect these features to affect the outcome of the model. So imagine you're building the predicting whether someone is going to re-offense. Like if you change the color of their skin, would you want that to affect the outcome? Like, probably not. If you change someone's gender in a job application predictor, would you want that to affect the outcome? Again, probably not. So consider deliberately excluding these features or only including the features which you already expect to contribute to the outcome. Consider adding tests to your model where you change a single feature and then measure how much the prediction changes. However, even if you do this, this is not a guarantee against bias. Certain features may be used as proxy features by the model for the excluded feature. So if you consider the US criminal justice example, we can exclude someone's race from the data, but their address or postcode or school may be just as good a predictor and may act as a proxy for their race. So this model would still be biased, but in a less obvious way. And it's not clear how you would avoid this kind of problem. The second thing we can do is to build explainable AI. So machine learning models which are used in business settings and really in any real-world application need to be explainable. In any case where they affect people's lives, where the outcome of the decision will affect someone's life, then they need to be explainable. So from the very beginning, just try to consider how your AI will explain the decisions that it makes, and consider having a human in the loop where certain decisions are made by a human or the process after a certain point gets taken over by a human, as in the KYC example. So the importance of transparency. It seems that having explainable AI is something that should be kind of required by law, by businesses. So we have the GDPR, and one article of the GDPR contains the right to an explanation provision. This gives an individual the right to ask for an explanation as to how that decision was reached, or to ask for a human to make the decision instead. However, this has a number of limitations, so it doesn't apply if the process is only semi-automated, so if it's a human who ultimately makes the decision. So if we had a similar algorithm to the Compass, the US Justice Court algorithm in the UK, and that was used to try to predict whether someone should receive bail, because the judge ultimately makes the decision, the person would then still not have a right to ask for an explanation in this case, because it's only semi-automated. Also, if the decision does not produce a legal outcome for the subject, then they don't have a right to ask for an explanation either. So it's quite a small number of cases where someone has the right to an explanation, according to GDPR. So imagine if you were sent to prison partly because of this tool and you didn't even have the right to know why. So AI is sounding maybe pretty bad at this point, so it'd be great to kind of redeem it a bit. So we don't just want to avoid perpetuating existing bias. It would be good if we could use the power of AI to eliminate this bias as well. So with the criminal justice example, this data exists because the bias already exists in the system. The data is, in some sense, it is neutral because it's just an accurate representation of the system. Unconscious biases influence human decision-making at every step of the process, in every field, in some way that we might not be aware of and might be difficult to measure or to prove that they are, even. But what if we could use AI to remove the influence of unconscious bias in certain instances? So these are some more statistics on the US criminal justice system. I just found this case quite interesting, so that's why I've talked about it quite a lot. So if a judge is granted bail on 4 cases in a row, the chance of the next person being granted bail drops to very low, regardless of the individual case details. So this seems like a kind of strange anomaly. It seems like it's something to do with judges trying to be fair and trying to, yeah?
There was a study written follow-up that showed all that was untrue, actually.
Oh, really?
Yeah,
oh.
Which I wrote about.
The only reason I know is because I thought this is a bit strange. The idea that judges are made more lenient judgments after lunch. I don't remember the system like that. It turned out that it depended upon the sequence of who you put before the judge, and they tended to deal with the easier cases immediately after lunch and the harder cases later on. And the obverse explanation for judges being harsher as lunch came was that judges wanted their lunch and were being less lenient. But in fact, again, the priority of the cases was that the easier cases were put first and the harder cases last. So it was about the prioritization of the cases and not about the judges wanting lunch. But that wasn't picked up in the initial study, but it was in the corrected study. And therefore, the statement, algorithms when I have these idiosyncrasies, is not necessarily true.
I have
because
this.
you just demonstrated that they're biased as well.
Yes, the algorithms. Yeah, that's true. But when I wrote this, I meant specifically the lunch idiosyncrasy. I don't think the algorithm would have, and that each case the algorithm assess individually. So any kind of bias in terms of the series of cases made by a judge, the algorithm wouldn't have that inconsistency. But I also have a note here that says this lunch claim is slightly contested. So I just thought I'd put it in because it seems like...
No, it's fine.
No, that's interesting. Yeah, thank you.
I know because I followed up, and not many people did, including people who've written books about it.
Oh, okay.
They quote this example time and again. Judges making harder judgments closer they got to lunch and more lenient ones after lunch.
It does seem like a bit of a weird example, but luckily I have some other examples. So these are more examples of inconsistency in judges' verdicts, so feel free to contest this as well, because you may know more about it than me. So in one study, which was carried out in the US, this found that when 47 judges were given the same case study to look at, 29 declared the defendant not guilty and 18 declared her guilty. So that's already a bit of a inconsistency. You'd kind of expect at least most of them to declare the same verdict. Otherwise, it seems as though when you go to trial, your verdict depends on which judge you get, which maybe that is the case. And of those declaring the guilty verdict, 8 recommended probation, 4 recommended a fine, 3 thought probation and a fine, and 3 were in favour of jail. So there's also quite a range of different verdicts happening there. And in a second study, and this one carried out in the UK, 87 judges were asked to look at 41 hypothetical case studies and decide whether or not to award bail. There was not a single case study where they unanimously agreed, but I guess 41 is a lot, so maybe there was one that, I don't know, most of them agreed, but not a single one went, sorry?
Why in those cases they didn't agree?
I don't know, just inconsistency.
Did they like look into that? Why?
Oh, okay, yeah, I'm not sure. I don't know about the background. I have the paper here if you want to.
There was also another study that said that despite that evidence, people prefer to be judged by a human being.
Yeah, I saw that as well.
An algorithm.
Yeah. But then there was also, I read something about a judge was asked whether she would want the decision about her verdict to be made by a human being or algorithm. I think she picked the algorithm and said that she didn't want human bias to be influencing the decision. Yeah?
Certain things that, like, if you're used to, because, like, we know the judges, like, we know judges, but we don't know algorithms. But actually, if I know that they won't be biased or will be less biased than the judge.
So it might take time to actually people get used to it and accept that it's actually better.
Yeah, and if you know that it's fair and unbiased and you kind of see that it is, then yeah. And the second part of this second one was that 7 of these cases were exactly the same, but with the names changed. And the majority of judges didn't even make the same decision on that case when they saw it for the second time round, when the case details are exactly the same. So that's also a pretty strange
How couldn't they know that it was the same case? They're smart people, that doesn't make sense.
Yeah, I'm not sure. So this is... This
No, look, it's the same facts, right? It doesn't make sense. So they would know it's the same case. Like, they're not stupid, right?
But isn't the conclusion that you need both the algorithm and the judge?
I guess that is inclusion, although also it seemed from what I was reading, the judge is often very influenced by the algorithm. So.
There's the same case in healthcare, for radiology. The same radiologist will not interpret the same scan. Similarly, if seeing people. Similarly, the algorithm will always predict much better than the radiologist, which begs the case, do you like dehumanize the process and remove the radiologist, and then potentially get a better predictability?
But what if you have a rare case then?
Yes, and there is cases of that. Usually, even in that case, it will be better.
Even in that case, it will still be better.
I think the issue is often the ability of people to understand probabilities, and people are really quite poor at that. I guess that comes to bear whether or not to trust a machine or a human.
Yeah, so I guess this is a case for AI in eliminating inconsistency between fallible human judgments. So I think for also in our KYC process, we eliminate inconsistency between human case handlers. I think we found that like occasionally someone would be just a bit more stringent than someone else, and that's not something that comes up when we're using the algorithm. So this is just another random example that I have. So in general, AI is good because automation can help as it decreases the cost of certain services. So for example, with our document reading example. So one example of this might be in giving legal advice to people who can't afford a lawyer. So if you imagined a similar model to what was used in the US justice system, trained on a bunch of historical case studies, someone who can't afford legal advice could maybe enter the details of their case into it, and it could come up with predictions for their sentence or for whether they'd be granted bail. And this seems like a low-cost way of better informing people when there's a lack of access to legal aid, for example. And I feel like in these kinds of situations, the negative consequences are very low or non-existent, as opposed to the case where the AI has been using to make the decisions. So this is just an open question, but who is responsible for making AI ethical and explainable and unbiased? Is it the machine learning engineers building the model? Is it the companies who are building the applications that are based around the model and selling these applications to other companies and to individuals? Or is it government bodies and regulatory bodies for regulating the use of algorithms and enforcing transparency in AI applications in legislation such as GDPR? Yeah, that's kind of an open question, I guess. I personally feel like it should be every level of responsibility, and that engineers have a kind of moral, if not legal, responsibility to make sure that the models they're creating are unbiased and are explainable. This is just something I kind of thought about. It's, can we ever fully eliminate bias in algorithms when the data might always be fundamentally skewed? Because a bias is just a pattern in the data, which shouldn't exist. But saying that it shouldn't exist is a kind of moral claim of fairness that we're making. We're saying, like, your race shouldn't impact on your sentence length or whether you should be granted bail. But we can recognize that this is an unfair pattern, whereas the algorithm is just another pattern in all of the other patterns in the data. In the US justice system example, can you think about which features you would input into a model which would make it totally unbiased when trying to predict whether someone will reoffend? Yeah. So in conclusion, the problems we face is that AI built around biased data will create biased models, and using biased data can perpetuate existing inequality or unfairness, or even make it worse in some cases where you're automating processes on a large scale that are going to affect a lot of people. And AI is increasingly being used to automate decisions or to semi-automate decisions which have a significant impact on people's lives. And even in the cases of semi-automation, for example, in the case with the judges, people place their trust in algorithms and they don't understand how they work, they don't understand why they're making the predictions that they're making. However, the upshot is that AI can possibly also be used to help remove existing biases in the case of inconsistencies, and automation is in general a good thing and can increase efficiency and cut costs in general. But the main takeaway is that AI needs to be explainable to be truly ethical, if you don't know why your machine learning model is making the predictions, how can you even know whether it's biased or not? And transparency and understanding of any AI, I'm using AI in a loose sense, any AI and technology is needed at every level. So, yeah, that's the end. Thanks for listening.
Santi?
That's very interesting. Thank you very much. I learned a lot. When we compare the performance of your AI tools, say for making loans, with what you call humans case handlers, do you assume that the case handler, the human, is unaided by technology or uses all the generation algorithms? Because I don't know any bank anymore whose clerks do not use existing algorithms of a different type. They're not data-driven. So a lot of the problematization is exactly the same with the problematization of using logic-based analytical algorithms of 30 years ago. And these algorithms are already in use. So I wonder, this problematization that you present now, and more specifically, the performance test that the industry does, whether it discards completely the technologies in use and compares the unaided human mind with the new tools, or somewhere there are interesting tests and comparisons to be made with the older type of algorithms, which were discredited at some point because they reached a dead end, but this technology might also reach a dead end. We don't know yet, although you already gave a number of examples that suggest so. So what is the thinking in the industry about this? What kind of different variety of tests are actually made, and what we learn about different technologies as well? Interestingly, the previous speaker compared different models, although I suppose they are both of them the latest type of the data-driven.
Yeah, so I can talk about what we did for the Know Your Customer example. So I don't know what technologies they were already using to complete KYC checks when we started, and I didn't actually work on this project, but we compared our algorithms to whatever they were doing in the bank at that time, and I'm sure they did have some kinds of like rules-based checks or technology behind it. We definitely didn't compare it to people without access to any technology. It was compared to what the bank had at the time. But I feel like one of the main issues that I've kind of seen that banks have is that they can't really move beyond the technology that they have. It takes a really long time for them to adopt some new technology and to like automate some process. It's like they'll have a document and they'll be typing like fields from that document into some other like software because they have no way of automating the extraction of information into that software. So yeah, I guess I would hope that like not all the technology is just thrown away, and I don't know what technology we use to build our algorithms that was maybe based on what they already have. But I think what you said about rules-based algorithms, and that it kind of reaches a point, like a kind of maximum accuracy, I guess. Whereas like, I would hope that the technology that we have now will continue to improve until it's a higher accuracy than rules-based algorithms. Does that answer your question?
Yes, certainly. Thank you very much. I'm not sure it reached the dead end because of accuracy or because of the pragmatics of how much value companies got out of it. But it's a very interesting thing that there are alternative ways of creating various kinds of assisted or non-assisted artificial intelligence. At the moment, we put all our might in data-driven, and most of the things that we talk about is statistics and data. But there have been other technologies, and I think at some point we'll start comparing them, and it will be a good thing to do such comparisons.
Could I add to the answer too? So I've been working in a bank for the last 20 years. So I've seen the dinosaur technologies that we have worked with before and how it's also moved forward, because then I'm also working in big data and AI. So, and there are a number of things that contributed to allowing us to harness the power of AI. So when I first started, everything was very manual. But we were also very much limited by how fast our service could run.
because we were buying all kind of CPUs and so now in the last few years we're seeing that we can run on GPUs. So from a selective risk management perspective, where we previously would have calculate our risk management figures that might take months to calculate the number of simulations, but we using GPUs and using neural networks by putting the functions into a neural network, we can fully accelerate it and we can run in a matter of hours as opposed to a number of months. That's one thing. The second thing is around the evolution of algorithms around, say, natural language understanding, which I think we touched on unstructured data. Previously, when word embeddings came about, we can now understand how people structure sentences. We can understand the context of a sentence, and we previously we didn't have that until about 3 years ago. So I see that we have improved, but yes, then now the question comes in with the ethics of AI. Might that lead to now creating a new AI winter because people are hesitant to entrust this technology and to actually productionize it because it will impact people's lives?
That's a very good answer, and of course the ethics is the topic here. But from your answer, I understand that we have had an evolution of different technologies, but we tend nevertheless to think about AI as machine intelligence or just bare human intelligence, which is misleading.
Yes, and it scares people too when people talk about the singularity, when the human being overtakes, when the machine overtakes the human being. I think we're quite far away from that. We haven't get to the point yet. But yeah, it is a scary leap to make to allow machines to dictate decisions.
Any other questions?
Kissinger wrote an article about that recently, about transhumanism and all that. So it's a legitimate fear, a lot of policy makers are afraid of that. So
I think it's scaremongering, right?
We see a lot of dangerous things happening to many people, like people get fired because the machine learning did something wrong, or people lose money. So there are things that happen. Maybe they're little, you're right, maybe they're not as big as other mistakes or problems that happen because of human error, but it's a legitimate fear.
I mean, there are a lot of machine learning projects that also fail. And having worked so long, and people always come to me and say, can I have a bit of AI magic? One, there's a good way of getting funding. Two, people don't always understand the problem they have before they implement the AI project. And if you don't understand your problem well enough, you will always fail. So, like all the projects I find, you see 90% of them actually do no production. And it's because people don't understand what the real problem is. They just want to say, I've used AI just because it sounds sexy.
So it's like a marketing thing.
And just the last question. Do you have a question, Harry?
Actually, on this topic, Elon Musk is quite concerned. He is concerned, I'm concerned as well. But no, I think, generally speaking, to all the speaker tonight, I was wondering while I was reading the title of the event. Actually, how can we have an ethic AI if we don't have a global ethic? How can it be ethic if I think something because I'm from Europe and someone from China or Saudi Arabia will have a different perspective on that? For instance, there is this social experiment. Will you save your kid, your mom, or your spouse? And Americans would save the spouse, so he's the biggest love of your life. I would personally save the kid because I'm European. And Saudi Arabian will save the mom because, well, you have just one mom. So how can there is no right or wrong. So how can a machine actually make a decision that will make people happy about it? That's my question.
I guess it goes back to, you had a good slide which said, who's responsible for taking the ethical position? Is it the supplier? Is it the company consuming it? Or is it the government? And you said all three to some extent. Because that illustrates that, doesn't it? Because that supplier could be someone from the other side of the planet that developed that tool in a very different kind of ethical framework from what the destination business is. And they're implementing it maybe in a different country to what their native basis. So it does strike me that it's a very complex world, but ultimately it's that business consumer who needs to be AI ready and cannot outsource essentially the ethical issues around using that tool. And I think that's the biggest challenge facing industries is how we become AI ready so we're knowledgeable consumers of AI rather than blindly taking a lot of this hype and potentially biased rather than from third parties.
Yeah, and also as suppliers as well, I know there is a kind of advisory body that speaks to governments around the world to kind of look at these are the developments we're making and these are how they can be implemented, and these are how they could affect X, Y, Z policies that we have going on as well. So it's not just in the UK but in the US as well. So there are those discussions happening. A lot of it hasn't been solidified yet to be able to say this is a set law right now, because everyone's trying to get through that understanding period. I mean, if you watch the House of Commons interviewing anyone who works in a technology company, it's baffling. Like, they don't understand it at all. So it's still very slow. As you said, we're 7 years behind in terms of making legislation. So I like the moves there. But it is that amazing thing.
Great, thanks, Rose. Those are excellent. So just to wrap up, just to thank the speakers again, and I guess almost everyone here is a student or alumni, are they? Is there? No. So we have. Well, we'd just like to. If you're going upstairs here on the 5th floor of the old building, we have free drink and some snacks. So if we can just we might maybe have a informal chat there as well about how we would use the alumni network in order to, to make it more useful for ourselves. Yeah. So does everybody know where the 5th floor of the old building is? Yeah. So if there's a few people that don't know, maybe if everyone else can guide them up there. Yeah. Thanks very much.
Oh, thank you very much.